In this video tutorial, I'll be explaining about how to port FreeRTOS onto Arduino UNO board and verify its output on the Proteus simulation software. There are 7 steps involved in porting in a FreeRTOS into Arduino UNO and verifying its output on the Proteus. In step number 1, we'll be downloading and installing the Arduino IDE. In this case, I've taken the version 1.8.12. And step number 2 will be downloading a FreeRTOS library and add them into the Arduino IDE. Step number 3 will be performing an open and copy operation of the blink_analog_read.ini example program. And step number 4 will be creating a new Arduino sketch. We'll paste it and then we save and modify to generate the .x file. And step number 5 will be downloading and installing in a Proteus design suite simulation software to verify the output. And in this case, version 8.6 Professional has been used. In step number 6, we will be performing a download and add operation of Arduino UNO library for Proteus. And finally, step number 7, we'll be creating a Proteus schematic and we'll be loading the X file what we generated in step number 4 and we verify the output functionality. The link for various softwares which are being used to perform this demonstration is given in the description section. Let's go with the step number 1, which is to download and installation of Arduino IDE. In this case, I've taken 1.8.12. Go to the link which is given in the description and download and install this Arduino IDE version 1.8.12. So I'm copying the link. And that will be navigating to this page. So get into a section called download the Arduino IDE. In that, go for performing installation through a Windows installer. And it will try to open another page where you have to click on this just download option to perform the download. Upon successful download operations, we are going to install this Arduino IDE onto our system by clicking on that .exe file. So now ask for permission for installations. Give I agree, next, install. So this process will enable you to install Arduino IDE platform onto your system. After successful installation of Arduino IDE onto your system, you'll get this message completed. Once it's verified, then you can click on close. Now if you go and look into the desktop, I have this Arduino 1.8.12 Windows versions which I downloaded from the web link. The second will be the shortcut for the Arduino IDE. So if you try to open this Arduino IDE, it asks for admit permission. Please enable provide admit permission. So in this case, we have successfully installed this Arduino IDE. In step number 2, we have to perform 2 operations. One is downloading a FreeRTOS library from the web link given in the description. Second would be adding that library into Arduino IDE. So this is where the actual FreeRTOS programs have been present. We are going to add as a library in our Arduino IDE, and later we'll be using those example programs to modify and will be used for our own application development. So let's move on to the web link given for downloading Arduino FreeRTOS library. So there are many version of Arduino FreeRTOS library presents, and the one which is very recent is FreeRTOS 10.3.90-9, and I'm going to download. So if you wish to use some other version of the FreeRTOS, you can download the same from this page. So I'm clicking on, so this is allowing me to download the FreeRTOS library for Arduino. So as you can see, the file has been stored on my desktop locations with the file name FreeRTOS 10.3.0-9. So this is the file that holds the Arduino FreeRTOS library. So after performing this download operation, we need to perform inclusion of this library into Arduino IDE. For that, you have to get into File. Sorry. For that, you have to get into Sketch, Include Library, and look for option called Add.zip library. So it will ask for you to locate the file. So get into the desktop. So this was the Arduino FreeRTOS library which I've just downloaded. So I'm going to click on Open. So when I click Open, so in my case I'm getting this copy error message because I've already tried many times to include this library into my Arduino IDE. Since it's already available in the cache and registers, it just shows me that this particular library is already existing in our Arduino IDE. For your case, you'll be not seeing this kind of an error message. So since I tried already and I've installed that library into my Arduino IDE, so it is giving me this message that copy error message. For your case, it won't be any problem. You will not face any error. So once this has been successfully completed to verify whether the Arduino FreeRTOS library has been added to your Arduino IDE or not, get into File section and go to Example. Under the Example section, navigate to the bottom. You will find an option called FreeRTOS. So once you get all this kind of example programs under this option, then the library, whatever you have added, is successfully added into your Arduino IDE. So you need not to worry about any error in the inclusion of the RTOS library. So once this has been done, the step number 3 would be opening up and copying the blink underscore analog read.ino example program. So get back to the Arduino IDE. In step number 3, my aim is to open this example. So I'll show you where this example is available. So this is the example which we are looking for. But already I've opened this example in my Arduino IDE. In spite of that, I'm going to open it again. So this is what the example which I'm talking about, blink underscore analog read. So once you open this, copy this program by performing Ctrl-A, Ctrl-C. Now we will be moving on to step number 4. So in the step number 4, we need to create a new Arduino sketch, and we have to paste the program whatever we copied, and then we need to save that program and modify and generate .x file. So why we are trying to do step 4 here is, if you're trying to modify the step 4, which is a default example given in the library, if you wish to modify this, that will not be further used for any other operation. In addition, this particular memory location, the program memory location, require certain permissions to perform on the generates.x files, which cannot be permitted by the Windows. So we try to create a copy of the same program, and then we'll be pasting, and then we'll be performing a save operation, modification, and then we'll finally generate the X file. So let's work out on step number 4. So whatever the content I copied from the Arduino blink underscore Arduino read, I'll be creating a new sketch. The new sketch, I'll be selecting this program, deleting them, and then pasting whatever I copied. So this is a program example program of blink underscore Ardunio. So I'm going to save this program. So Control S. So I'm going to save the same location where the Arduino has been installed with the name FreeRTOS Arduino. So once you copy this, just verify whether it is able to compile it properly or not. So I'm not getting any error. So meaning that it has successfully got compiled. So prior to that, we need to modify this program as per the Proteus Arduino UNO library requirement. Then we'll be generating the X file. So in step number 4, we try to perform a creation of a new Arduino IDE, sketch. Into that we are pasting the copied program. Then we are going to save the program as FreeRTOS underscore Arduino. Now we need to modify this program as per our requirement. So the modifications are very minimal. Wherever you find LED underscore built-in, you need to replace that with 1 3, because the Arduino UNO model present in the Proteus software doesn't have an inbuilt LED onto them. So we are going to externally connect LED to the Arduino UNO board, and then we'll be verifying that output. So we are modifying this value LED underscore built-in as 13. So output represent that will be configured as output function, and it will be passing high and low. So let me explain about what has been done on this particular program. So in this program, they try to do a two operation, as they mentioned in the example program title. One is blink operation, other one is reading the value from the analog channel. So whenever you start programming with FreeRTOS, you need to include the Arduino FreeRTOS library using this as include operation. Next is you need to declare what are the tasks which are going to be get executed. So in my case, there are 2 tasks. So I'm declaring them as void task blink and passing the void PV parameters. Same way, to indicate the analog read operations, I've created another task analog read. And any configuration related operations you need to perform under this void setup. So in my case, I'm going to configure the serial port under the 9600 baud rate, and this is going to happen continuously, monitoring the serial monitor. And we have a loop function where we have to make it nothing inside of this, simply make it as an empty. And apart from this loop function and the setup functions, we are going to create a program inside the setup, so where we'll be creating in a 2 tasks. So for creating in a task in FreeRTOS, the format will be x task create, and then you have to mention the task ID what we create, and the user defined name, the amount of a stack what you're going to assign for the task, and whether you want to pass any variable to that, and priority. So further you'll have a null statement. Similarly, the second task, you'll have a task analog read 128 null 1 and null. So once you successfully created this task, and when start the execution, it will go and execute this x task create. where we specified what is the program it's supposed to get execute, which is task blink. So it will go and execute the task blink program. So the task blink, as I said, we have configured the port pin 13 as output port, and then we are making to perform a blinking operation with a delay of 100 millisecond, which is nothing but 1 second delay. So the meanwhile, in the second task analog read, we try to read the analog channel A0, and then we are passing to an integer variable called sensor value, and we'll be continuously printing this value onto the serial monitor of Arduino UNO with a delay of a tick delay or approximately 15 milliseconds delay. So there are two operations are being performed under this example. One is blink and the other one is analog task analog read. Blink is to perform a blinking operation of the LED connected to pin number 13 for every 1 second, and the task analog read is going to perform a read operation on the analog channel A0 for every 15 milliseconds time period, and then print that value onto the serial window. So this is the logic behind this program. Now, whenever you are using in a simulation software like Proteus, you need to upload in a .x file for its programming. But by default, if you perform in a compilation operation Arduino IDE, it does not generate the .x file. So to enable your Arduino IDE to generate .x file, you need to get into a section called File Preferences. So under the preference, by default in your preference window, you will find this option called Show Where Was Output During. Here, compilation and upload functions are not being enabled. You must enable the compilation operation. So this will allow you to generate in a .x file. So I click OK for this case to generate. Now we go for compiling this program. So you can see it done the compilation successfully, and I need to find out where this X file have been generated. So for this, get into this console window and look for the link with extension .x. So this is where my .x file for this particular program has been present. So I'll be needing this link when I try to do an upload operation on the Proteus software. So with this, we are completing step number 4, and we'll move on to the step number 5 now. So in step number 5, we must download and install Proteus design software. Again, for this, the link is given in the description section. So let's move on and download this Proteus design suite software. So it will navigate to this page, and then you have to navigate to the bottom, click on download now. It's going to be a 248 MB file. It will take some time to download this file. As you can see, the Proteus professional version 8.6 has started to download on my system, and it's going to take for a while, so we'll wait till the download completes. Now you can see on my desktop, I've successfully downloaded my Proteus professional version of 8.6. Now I need to perform installation of this Proteus design suite onto my system. So double click on this and create this, try to extract. So here I got my exe file, and this is a cracked version of the Proteus software. So you can simply go for executing the installation file to install a Proteus 8 onto your system. So let me go through the steps again. So this is a step number 5, where we try to perform a download and installation of Proteus design software. On this particular video, I'm trying to show you how the file, whatever we generated, that is .x file for the example, whatever we generated, will be loaded onto the Proteus design suite and will be adding the necessary components to visualize the output, and then we verify its functionality. So now I got my Proteus design software successfully installed in my um, uh, system. So I'll click on this to open this software. So get into an So step number 5 is successfully download and install the Proteus design suite version 8.6 professional. Let's move to the step number 6. The step number 6, we must download and add Arduino UNO library for Proteus, because by default, when you get in a default version of Proteus, you will not find this library called Arduino UNO library. This is where all the boards related to Arduino will be present. And for our case, we are going to use Arduino UNO. So we need to add this library onto our Proteus software, like how we did it for the Arduino IDE to add the Arduino FreeRTOS library onto the IDE software. So to do this, I've given the link in the description. Just step number, to perform this operation, the link is given in the description. Go to the link, copy this link, and then go for download. Once you get into this page, go for performing download library for a Proteus. And that will be navigating to another page where you need to wait for 20 seconds to perform this download operation. So the file required for adding Arduino library are being downloaded onto my system. I'm going to extract them now. So right click, extract the library file here. So now I can see inside this file, I got two files with extension .idx and a lib, and we have to copy both of this file and made it available inside the library folder option of a Proteus software. So for that, I will suggest to perform the cut operation, Control X, get into the installed location of a Proteus by clicking on the shortcut of the Proteus software, get into Open Files location, and get into previous folder where you'll find in a folder name called library. So into this, right click and then paste. So since, as I said, already I've installed this library, it's asking for permission to replace the same. So I'll give a permission replace. Since it's a performing operation on the C folder, it is asking for all this permission. So give S for all. And finally, after which you'll be getting these two files being present under this Proteus 8 professional library folder, Arduino tip.idx, Arduino tip.lib. So once this has been done, we have successfully added the Arduino UNO onto our Proteus software. To verify that, we need to check the available parts. So for that, we have to get into a step number 7. So in step number 7, we are going to create a Proteus schematic, and then we'll be loading this X file and then verify the output. So let's move on with the file, new projects. So I'm going to create a new project. which is FreeRTOS demo. Click on next. So I have the same name, existing name, same name. So I'm trying to replace that. So click on create a schematic for the selected template and do not create a PCB layout. Click on next and then no form of object. So with this, we have created a schematic for the schematic file for our simulation operation. So once you get into the steps, we need to access Arduino UNO and other important components which are required for this project. As I said, this particular example is going to perform the two operations. One is blink, other one is going to be the analog read operation. To perform the blink operations, we need an LED, and then that has to be connected to the ground in the one end, other end should be connected to the Arduino UNO board. And for the analog read operation, we are going to need a potentiometer. One end has been connected to the supply, and the other end is going to be connected to the ground. The middle pin will be taken as an input to the analog channel A0. Let's do that operations. So first we need to access various parts that are being required to implement this example. So get into the parts, type Arduino. So as soon as you type, you'll get a lot of Arduino UNO boards that are being present in your system. So where you have to select Arduino UNO. So this is the Arduino UNO board. So click on OK. So as you can see, the Arduino UNO board is added. So likewise, you have to add additional parts which are required for other functionality. So as I said, we require a pot. So there is a pot called pot XG that will allow to change your resistance value during the runtime. So click on OK. This is the second part what I need. The next part what I need is LED. So LED green. So this is LED what I require to perform the blinking operation. Click on OK. So these are the essential component we require. So first we get the Arduino UNO, click on this and then bring it to your schematic drawing area. Click once, so you'll get the Arduino UNO board. And so this is Arduino UNO board. As you can see, it has all the external pins like in a normal Arduino UNO board, but very importantly, the inbuilt LEDs are not being present here. So that is why we purposefully given a pin number 13 to perform the blink operation. So next, take the green LED, place it near to the 13th pin of Arduino UNO. Then take this selection mode operation to perform the wire connection. Next is I need to perform a ground connection. So for that you can get into terminal mode, ground, draw the wire first, then double click on it, then you paste the ground. Same way to connect, sorry. So same way we have to consider the potentiometer connection. So take the potentiometer, connect here to A0 pin, and as you can see there are 3 pins available here, and this is to be connected to positive, and this will be connected to negative, and this will be connected to the analog channel. So perform this, get into this, click on power, same way make a connection for the ground, and finally make a connection for the analog channel 0. So once you successfully make necessary connections, we can go for simulating this program output. Prior to that, Arduino IDE, the task to trying to read a analog value from the variable resistor and then print it on the serial window. In this case, we don't have a serial window available here, so we are going to have a virtual serial window. So that is available on this section. So on the section called instrumentation, you can find an option called virtual terminal. So double click on this, place it here, and then you have to make a necessary connection for the virtual terminal. The connection is very simple. RX to be connected to TX, and a TX of this will be connected to RX. So RX to TX, and the same way TX to RX. So this is the connections which is required for verifying your output on the screen serial window. So now we successfully created the schematic. So in step number 7, we need to create a schematic for the example which we have taken, and the next step would be uploading the X file. So now it's time to copy the X file locations from the Arduino IDE and then pasting them by clicking on this UNO board, double clicking on this UNO board, and then pasting inside this program file. So this will allow the Proteus software to read the X file that is located on this memory location, then start uploading onto the UNO board. And whatever the functions being present, that will be tried to execute under this schematic. So click on OK. Now the program is uploaded here. To verify the output, I need to click on this run button. So I'm trying to execute this program.
Now we can see it on the serial monitor window. It is printing the value of 512, which represents the current value what we are getting from the port which is connected to A0 in terms of a digital value. Since the Arduino is having an inbuilt 10-bit ADC, whatever the analog signal we will be giving, that will be converted into a minimum of 0 to maximum 1023 values. Since the position of this port has been centered, it's producing in a value as 512. And meanwhile, you can also verify the LED connected to the pin number 13 is made to glow. So this way, we have achieved porting of FreeRTOS on Arduino UNO and verified its functionality using Proteus simulation software.